And now we come to another topology which is also a very important topology called a ring topology. And the ring topology, computers are connected in a closed loop. All right. Now this has a lot of advantage. First, now how does it work? Well, the way it works is that the first node passes the data to the second node, the second one passes data to the third, and so on. So the data will go on hopping around the ring, and what will happen is that as it reaches the destination, and it will, if it goes around, if it is going around in a loop, it will surely reach the destination at some point of time. The destination will copy this. In practice, there is a short connector cable from the computer to the ring, so that is the actual technology, and ring connections may run past offices with connector cable to sockets in the offices. So this is an example of a ring topology. Actually, if you look at it, there are two rings here. So one ring, that means, so let us say we are using only one ring for communication. By the way, in a ring the data will always go in only, usually the data will go in only one direction. So this is a simplex kind of communication in that sense. So if your destination is on the wrong side, then the data has to come the whole loop and then reach the destination. So there is one ring for that. Now what is the other ring for, what is the other ring doing? Now there could be various reasons for putting another ring over there, and quite often we put two rings, or sometimes maybe even 3 or 4. Well, 2 is quite common. One way you could use it is that you could send data the other way in that ring. That could be one this thing. But a more important reason for putting two rings is that if there is a failure in the network, there is a possibility of still the communication still going on. Okay. So look at the picture B. So let us say one particular node has come down, that means it has there is some problem in this thing. The other, so what these if these nodes can sort of sense that this has really gone down, and so what they will do is that they will sort of wrap the ring around. Okay. So if you look at it, that physically, although this still this looks like, I mean, if you take out the one portion, this looks like a broken ring, but if you look at it as a single ring, this is still a ring which is going through the nodes. Okay. So these nodes can still communicate, although there is a breakage over here. Okay. Either this node may break or this link may fail, so many things may happen. So this fault tolerance is one good reason for using rings. All right. And as a matter of fact, especially in the wide area network, okay, in the wide area network we have lots of rings. For example, let us say these telephone exchanges. All right. These telephone exchanges are connected in some fashion using maybe fiber optic cables. So we will be talking about all those things later on, but they usually put them on a ring, because if the cable is cut at some place, they can still communicate by using the trick that I have just shown. Okay, so this is the summary of the characteristics of a ring topology. There is no beginning or end, it is actually a ring. So all devices have equal access to media. So that is one good thing about it, that all of them so get the data at some particular point of time, so they have equal access to this media. So in a single ring, data travels in one direction only. A double ring allows the fault tolerance. Each device has to wait its turn to transmit. That is that means you cannot start transmitting as soon as you want to transmit. You have to take your turn. And most common type is the token ring. So token ring is that has got again an IEEE standard number, that is IEEE 802.5. So in the token ring, what happens is that a token contains the data, it reaches the destination, data is extracted, acknowledgement of receipt sent back to transmitting device, removed, empty token passed on for another device to use. So that is one way how a ring can be used. For example, that means a token is of course some kind of data, all right. So, you make a data packet with this token as well as whatever you want to send to the final user. So, this whole packet you send over to the next node in the ring, okay. And this way it goes from, it keeps hopping from one node to another till in the when the destination gets this packet, it knows that it, I mean the destination address or some kind of identification would be there somehow in that whole bunch of data. So, the destination node will know that this is meant for me. So, he will extract the data, maybe he will put in an acknowledgement if you are using a protocol which uses acknowledgement, and send it along the ring. So, it will go around the ring and come back to the original sender, and the sender will know that this has this data has been received. So, what it will do now is that it will remove this acknowledgement also, and the empty token is passed, and this token keeps on circulating in the ring, and whoever wants to transmit, suppose there is a node C, let us say, which wants to transmit. So, it has to wait till it gets the token. So, as soon as it gets the empty token, what it will do is that it will put on the put in the data that it wants to send and send it along the same way. So, ring topology has its advantages and disadvantages. That means data packets travel at great speed. Now, one reason why data packets can travel at great speed is that this is a very synchronous operation. So, so that there is no question, if you remember that in a shared medium where the nodes are not synchronizing their actions, what might happen is that two different nodes may start transmitting at the same time, and then their data will go and collide in the broadcast medium, killing both the communications. So, here of course, such a thing cannot happen because it is all being synchronized with the help of the token maybe, or there are other ways of synchronization. So, we will come to all that later on.